Thank you. It's a pleasure to be here. I'm going to do something which not normally done in design conferences. I'm not going to be showing you any nice maps, images, or pictures. I thought about it, and I have lots of them. But I just thought, because it's early in the morning and most people are still awake, I'll just sort of talk to this theme, especially around the question of water, society, and socio-ecological systems, how that relates to sustainability, and what that's got to do with development, especially as far as development of this country is concerned. And while I'll start with some fairly simple ideas about what water and why water is important, I'll try and end with economics and politics, which I think is quite important. As designers, sometimes we stay away from that space, but as you get to work with more and more complex issues, we understand that culture, economics, and politics are essential to the sort of practice of any profession, and especially any profession that's got to do both with the built environment and the natural environment where these come together. So, to start, and to be sort of very provocative, I would say one of the problems that we really have is in how we frame and how we see things. And the first big challenge is, in some senses, our planet has got the wrong name. Our planet shouldn't have been called Earth, or even in the Indian tradition called Prithvi. It should have been called water. Because that is the nature of the planet. The planet is dominated not only by the oceans, but by the movement of water through the biosphere. And everything that we see, there are many limiting elements in the biosphere, but water is probably the most critical element in that. It is, in a sense, our anthropocentric terrestrial view of life that has led us to call this planet Earth. And even if you look at the movement of history and trade and a whole range of other processes, and India sometimes is a little bit myopic in this, the things that have defined what has happened in South Asia in some senses are, of course, terrestrial questions. We talk about movements and invasions that come from the north. But our connection with the sea and the centrality of the Indian Ocean in the last 2,500 years is something that we often forget. When you're sitting in Bangalore, maybe it's not so obvious that these connections are quite critical. But if you remember, the history of even this landscape has been defined by processes that have started overseas in many ways. The important thing to remember, especially in the early 21st century, is that the geography of the world is changing very dramatically. The 19th and the 20th century were all about the North Atlantic. That has transformed itself into the Pacific. But the 21st century is essentially going to be much of the economic activity of the world, much of the flows from oil to trade to people are going to be around the Indian Ocean and also the Pacific to some extent. So when we look at the world, if we look at the world from the point of view of a terrestrial organization, vis-a-vis looking at the planet as water, things look different. So the first thing that I was saying is that, if you look at the world as water and look at how water circulates, we tend to see things both geographically and otherwise differently. The second thing, of course, very simply, and I guess all of us play with this, water is actually a remarkable compound. In fact, in some senses, it's a meta compound because, those of us who work with it on the science side understand that water has structure. And you can see that if you see that visually. Every snowflake that falls in some senses is unique in history because it has a particular structure. That's related to its chemistry because of hydrogen bonding and a whole range of other things. But that structure replicates itself all the way from the micro level. A couple of water molecules actually bonding all the way up to the macro, and we don't see that. Again, as I said, it is in some ways our terrestrial bias of organization. The second thing is that water cycles. Water cycles continuously through the cell, through the organ, through the organism, through the built environment, and all the way up to the massive geochemical cycles that then, actually impact processes like we saw in Chennai, or we saw in Srinagar, or we saw otherwise. So that's another important sort of element, the process of cycling and connection, and the linkage at different scales. And I think, one of the wonderful things that we'll hear over the next 2 days is some of the masters in this business who will talk about these processes, whether it's ecological or in looking at the Ganga or trying to look at, this is Dilip and Alexandro and a whole range of other people. So you'll have an opportunity to look at this process at scale. So water really gives you a way of actually connecting between scales and also looking at closure at each scale. That's the thing. In some senses,
because it has structure, and also because water has memory, it does not forget. In some ways, it's both forgiving and it's also deeply unforgiving. And I think we have to understand that both as designers and people who intervene in the system. And I'm making this philosophical point, but in actual practice, like in many places, if you assume that the hydrology of a place gives you a fixed land and waterscape, if you look long enough, you'll find that you're desperately wrong. And we had images here coming up from Akbar and Fatehpur Sikri, and there's so many other. I mean, if you look at the history of settlements, it's really the history of this continual mistake that you think that water is forgiving and you can control it and you can actually sort of manage to build systems and agricultural and other sort of cultures on it. But in actual fact, it does remember. It remembers at all those levels. So being conscious of that is, I think, quite important. And that comes from the nature of the element itself and the understanding that the biosphere and everything that we have around us, much of life on this planet, is really defined by the relationship between this particular set of compounds and a whole range of other things. And the memory question is also quite important, at least in my experience, because it speaks to two things. At a very personal level, because water has memory, the quality of water that you ingest, it's not about consuming 8 liters. It's also the quality of water that you ingest actually determines the quality of your life. We often forget this, but every trace element that you find, whether it's critical body salts at one end or pesticides, which we bioconcentrate remarkably as human beings, actually situates and circulates through our system. So if you look at some of the most advanced work at the moment that comes out of the Fraunhofer Institute, X and Y and Z, the fact that water has this memory and that memory can be replicated within the body and otherwise is a basis for ancient healing traditions, and also the fact that we find more and more that environmental diseases, and the most obvious ones are air pollution, but environmental diseases that relate to water are sort of endemic in our society. What we call a whole range of allergies and other processes that have to do with the immune systems are all about disbalances in water systems. So it works all the way from the level of the health of the individual, you and me, and all of us in our urban environments, to the health of the planet. So that's, in some senses, sort of the opening statements I'd like to make. The other thing, if you step back again, is that we live in exceptional times. The 21st century is quite exceptional. For nothing else, because we now have about 7 billion people, we'll become 9 billion people. Most of the science and understanding, and even many of the design principles that we work with, have been developed in an earlier era and time in which the world was not full of people. So at the beginning of the 20th century, about 100 years ago, we had about less than 1.5 billion people. So over a period of about 100, 150 years, we have not only doubled and quadrupled, but almost increased the population of the Earth by 8 times. So a lot of what we've learned, especially in design, comes from an environment in which the Earth was actually relatively empty. Fine? And our relationship to the design of the built environment is shaped by that experience. And of course, because many of us have been influenced and have grown in an educational tradition that's influenced by the West, in which actually population pressures were much, much lesser than that in Asia. The assumption that there is an unbounded frontier underpins, in some senses, a lot of what our experience is. But of course, if we go back, and I guess we'll hear this again and again over the next couple of days, if we go back and examine the experience, especially of traditional, and I would say especially Asian cultures, where we've actually managed, whether it's in China or Southeast Asia or South Asia, etc., we've managed with very high densities of people in particular environments. The lessons are actually quite different. There is no boundless frontier. And in fact, water is the first limit that you come across that actually pushes back at you and tells you, this is not possible. What you're doing cannot actually be sustained in this environment. So we live in an exceptional time because, since the late 80s or early 90s, depending on which part of the world that you have, we have been living in a world which is in serious ecological deficit. So we're a species that has now co-opted more than half of the net primary production on the planet. Fine? So, plants and a whole range of other sort of beings photosynthesize and produce the net primary production, which everything persists, all our food systems, many of our ecological services. So we have, as a culture, not only this country but otherwise, have co-opted more than half of it. What does that mean? It means two things. It means that you're immediately putting any other species, all other ecological communities at risk, because you're taking away the essential energy flows in the planet. The tragedy, of course, for us is not only are we co-opting it, but much of what we co-opt into our food systems and our energy systems and other stuff is actually wasted, whether you look at food waste or you look at a whole range of other waste. So it goes back to actually, especially because we put chemicals into the environment just now, to actually disrupt those processes. So that's, I think, one core thing. So you have a dramatic increasing ecological deficit. We're consuming more than what the ecosystems can provide to us. And we are now starting to dramatically affect larger biogeochemical cycles. There's a lot of talk about climate change. I mean, I've been involved in dealing with this thing at science level and politically with the Paris conference over the last many, many years. But it's not only climate. Climate is the most obvious thing, it gets the press. But every other major biogeological system, whether it's the phosphorus cycle, the nitrogen cycle, and of course, most centrally, and we don't see that, the oceans are in a desperate situation. Why? I think partially because of this idea that if you have a landscape, you can actually situate yourself in that landscape, you can draw resources from that landscape infinitely, or more or less infinitely, driven by an economic system, and you can put back waste in that landscape, and nothing will actually happen to you. Now, in actual practice, excepting for some, historical agricultural cultures, including in India, but certainly if you go to Iraq, you can see it, in other parts of the world and in some parts of Latin America. And of course, industrial cultures starting in the 18th and 19th century, you actually found limits to what could happen. It was obvious if you went to New York and Paris and whatever it is, and London, of course, in the 19th century, in the 20th century, systems are just not working. People were dying because of what we were doing with the environment, and of course, the inequality with people associated with that. But we're now doing this at planetary scale. And because we're doing this at planetary scale, it's now coming back not only to affect the people who are actually doing this and consuming all the stuff that we do in Bangalore and large metropolitan cities across the world, but also in areas which actually are very poor and where the resource consumption is very little, which is, again, much of rural India. Why? Because it's coming back to us in the larger cycles. What earlier came back to us in smaller cycles and created, plague and disease and famine and all the other kind of stuff that's there, it's now coming back to us in larger cycles. And these cycles sometimes first take a long time to build up, so they have a lot of inertia in them. They take a long time to actually fix. So it's not like, you can press a button here or change this or do that and you can fix it. Some of these changes may take a few hundred years. In some cases, they may actually persist for a few thousand years. So this is an existential crisis that we have at the moment. A lot of people living using a set of assumptions which don't work in the current environment that we have, and serious challenges. And it's not only, we can't fiddle at the edges to try and do that. And water is central to this process. Because if you ask me, of all the major limiting factors, there are 7 or 8 of critical limiting factors, what we call planetary boundaries. Fresh water is probably the most important one. And this country especially, I would say at least for the last 10 years or so, and if you're an agriculturist or work with agricultural systems, you know this for much further, is in a serious crisis in terms of gross water availability, and effective water availability, of course, is terrible. I mean, if you spend time in arid, semi-arid areas of the country, you understand how difficult it is. And, farmers are committing suicide not only because of a whole range of things, but because of serious deficits as far as water is concerned. So what does that lead to as designers? The first thing is, we have to understand and accept that pretty much everything that we do is situated within cultural landscapes. So if you walk across the country, travel, and I've worked pretty much in every state in this country and worked on most continents in the world. Most landscapes that you see have actually been shaped by the action of people. It may seem like it's a wonderful forest and it's actually undisturbed, etc., etc. At the micro level, of course, today if you go even to Antarctica and you go to the Arctic, you find chemicals and you find plastic and the industrial society has created those kind of things. But even in our landscape, if you look at the Shola forest in the Nilgiris or other areas that we see as undisturbed, they're actually not disturbed. They've actually evolved out of a process of significant co-evolution. And in some cases, we've actually crashed some landscapes. We've actually destroyed them. They've destroyed their character. So the first thing that we have to understand is that we live in cultural landscapes. So the relationship between the culture and the systems of production, consumption, and living of the people and societies that live there and the landscapes are very closely related to each other. Now, before independence, we were largely an agrarian society, and even now, India is 70% or 68% urban and 68% rural and 32% urban. So we're still very much, in some senses, a rural culture. So the relationship between livelihoods, the landscape, and resource flows are very closely tied to each other. And if we're not able to sort of connect those, I think we often tend to make very, very serious mistakes. This is an old debate that I've been having with an old friend, professor at NYU just now, Arjun Appadai, who's a sociologist, and he talks about multiple scapes and the fact that now we have this great sort of service sector-led society. So we have a noosphere, and everything is all up there in the virtual world and on Facebook and stuff like that. But in actual fact, if you look at the limiting processes, it is the land and waterscapes that actually determine both cultural behavior and a whole range of other processes. And when you come down to the basic tenets of what actually determines what's happening, we have to understand the relationship between the two, both the land and the water. And if you understand that, and I guess we'll have wonderful examples of this over today, it gives you a much, much, much more interesting example. And let me give you, a concrete example of that. We're in the process of, I'm trying to build a university in this city, and we're in the process of sort of trying to look at the design of our campus. It's not very large, it's about 50 acres or so. It's situated next to a lake, or an old tank, let's say, part of a lake system, part of this Vishabhavati system that's there. It's located next to a reserved forest, at least a state reserve forest, let's say. So it seems like a wonderful site to start dealing with landscape, ecological design, and stuff like that. So when we started doing our base work, and we're doing it at the moment, we find some interesting challenges. The first challenge, of course, is that the water systems are deeply compromised. The water systems were designed, and I guess, Harini will talk about that later, they were designed to meet a very different set of needs and an imagination, even in the urban context, which has changed dramatically. Why? Because land and land value and a certain imagination of urbanism is what drives what actually happens. And the way we represent things in land use maps, for example, which have no relationship to processes that I've been talking about, the process of flow of water, energy, biomass, and of course the multiple cycles. When you're coloring something red or green or blue or gray in some cases, it doesn't actually appear. So the lifeline of that system, the water things, are deeply disrupted. Of course, there are cycles because of the monsoon. But what you find is, in the upstream area, the tank chain system has been broken because obviously developers and even the government in some cases, the BDA is one of the greatest sort of innovators in the space in the city, have been very effective in breaking down those chains. And then you wonder why there's not enough resources to do it. So lake conservation is very critical to what we're doing. And then I just did before yesterday, I spent some time with a set of very young but really good researchers who are doing a biodiversity assessment from the national, from NCBS. And they tell me 2 or 3 things. The first thing is that this landscape is completely barren and bare, which has been used as an agricultural landscape for some time. Biodiversity should normally be quite low, but it actually is quite high. Why? Because urbanization is growing in that area. So the question that you have is, if you have a patch which has a campus that could be ecologically designed, you have a lake system, you have a reserve forest which unfortunately has too much of eucalyptus inside it. In 20 or 30 years, how could you actually look at this as an urban refugia? Because if you look at what processes will happen, we know that there's a leopard that's there. So how will you actually enable the leopard to come to the system? And so leopard in a sense is sort of megafauna in some senses, but the more important things are where are the reptiles, where are the frogs, where are all the flora and fauna inside that process, where are the butterflies, where are the bees, and we're not talking about dorsata, we're talking about other bees that will actually make this a living system. And how does one enable those processes in urban context? And the question I was asking some of my colleagues on this was, look, do we actually have research sites in this country where we can try and understand what happens in the long range in cities? And of course, the answer is, and I know that because I work in this area, we do not have a single long-term research site in this country where we can actually map what is happening ecologically in cities. Now, this is a new trend. I mean, I know that because I'm part of at least one big long-term research study in the States. Baltimore has been doing this for the last 15 years. They are now large ecological research sites to understand, in the work that we do as landscape architects or ecological designers, how do we play with the science? How do we look at how the built environment actually interacts with this? Because these are conjoint. These are what we call socio-ecological systems. They work together. They are entrained together, and they often collapse together either because of ecological or other processes. So one of the things that I would encourage you to think about as a society, as a set of people who work on this is, you can practice based on principles that have learned from, people who've been before you, the professors that we heard about. You can practice based on theory that's built from other parts of the world. But if you want to really do something that has context in this country, I would imagine if you take 3 or 4 or 5 zones, and we do this for energy in buildings, you need sites in this country where long-term studies actually function. And we can track what happens to the patch dynamics, what happens to the use of water, of pesticides, a whole range of other things, to be able to inform the process of design. Because if the process of design is not based both on experience and practice and science and the dialogue between them, and of course, science is not all, chemistry and all this kind of stuff. It's also the social sciences. I don't think we will get very far. So when I'm talking about socio-ecological systems, this is in the Indian tradition, we understand this. The challenge for us is we often box these things into 3 different areas. So the economists deal with economics, the sociologists and other people, political scientists deal with society, and then designers and a whole range of other people and environmental scientists and deal with the environment. Actually, they're coupled. And it is the relationship between them that actually determines what actually happens over the long time, over the long run. And the idea of the whole practice of sustainability is related to moving between and keeping the balance between these forces, especially in a country like ours that's highly stratified, in which there are a tremendous amount of people who actually depend on their livelihood on agriculture at one end, but also other ecological services and the flows inside them. It's absolutely important for us to look at the relationship between society and the resource base. So to give you, an interesting example from the city. The city has one of the most interesting, let's say, water systems in the country. And why is that so? It has a traditional water system which you'll hear about, which is, has been there for a long time. But then with the growth that started, I guess, in the 70s and 80s, we decided to bring water from very far away, from a river system. Actually, this city is an anomaly. We have very, very few megacities in the world that are not either on an estuary or on the coast or next to a major river. And, this is a sort of fact of history in some senses. There are very few of them. Mexico City is another example, which is a little bit like that. But there are very few large cities of more than 10 million people, and this may actually be going larger than that actually don't sit next to a river. So we're drawing water from maybe 100 plus kilometers away, and we're lifting it almost, 900 meters above, which is, in some senses, an unsustainable practice. Yeah. However, the growth of the city, and in a sense, maybe the decline of the city will critically, at least in my understanding of it, and I've been saying this for quite some time, will be dependent on how you use this water. The water comes up, it's pumped across, and then what happens to it? Much of it actually leaks. And that's the fascinating thing about the city. We have many parts of the city where, you have water coming once in 4 days. People have sumps across the region. There's serious problems of water scarcity. And frankly, this is going to become much worse. And I can tell you that from the research that we're doing. We are running a large long-term research project looking at climate change. Climate is going to be a very, very serious challenge for the city. But the fact is, there's enough water at the current point of time to provide everybody, with so-called 24/7 water supply. But the fact is that in the central part of the city, because the pipes are leaking, they're 100-year-old infrastructure, we find 2 things happening. The water tables are rising in some parts of the city, rather odd. And we also are having very high nitrate levels. So there's immense amounts of pollution that are building up, which are actually reflecting in the health processes. So what's happening here? We've taken a center which is driven by the growth economy, by the functioning of global capital. We're extracting a resource which comes from another location. In fact, Kaveri Phase 4 and all the water that's there, this is for people in Bangalore, is almost over. So we're now looking at other ways of doing stuff, taking pipes further out. And if you look at most Indian cities and now the largest cities, even Mumbai, which has a fantastic amount of water resources, we are drawing water from further and further away. Some cities are actually drawing them from 600-700 kilometers away. So the question I have is, why is this happening? Supreme Court, of course, has said that drinking water is, the top of the whole pyramid, and anybody else has to sort of take less in the pecking order. But is there some deep problem with this process? And I think there is, because again, it comes from this frontier mentality. You can situate human activity in an ecosystem. You can extract from as far away as you can take. You can increase your ecological footprint as much as you can, and nothing will come back to you. But in actual fact, we know from history, we go back to the Indus, you go to Dholavira, you can see it. You go back to Fatehpur Sikri, you can see. You can go back to lots and lots of examples. They are actual physical and hence ecological and hence economic and hence political limits to what this can happen. And we're doing that again and again and again. So when I look at what's happening, what happened in Mumbai in 95, what happened in Srinagar a few years ago, 2 years ago, and what happened in Chennai, there's a thread that connects between that. And what is the thread? The thread is, and Chennai is a fascinating example because it's a city that's actually done tremendous amount of, in practice, in terms of water conservation. It's one of the cities that actually in some ways has turned the corner in dealing with efficiency and reuse and a whole range of things. Of course, it does desalinization. But what's the challenge? The challenge is we do not look at ecological resources in a continuum. When I look at it from the climate science point of view, floods and droughts are both ends of the spectrum. They're both extreme events where an average rainfall, the stuff that we designed for, both ecologically and as engineers, is in the middle. That's the median. So a D1 or a D10 event, whether it's flood or drought, are both extremes. We know from the climate science that we have that two things will happen. The first thing is extremes will become worse, number one, and they will become more frequent. And what we are seeing, either in Kedarnath or in Srinagar or in Chennai or in Mumbai, is not climate change. This is a regime that we call climate variability. This is just the beginning. It's just a signal to us, people wake up, life is going to be difficult for you. Yeah? And they both come together. So what happened in Chennai? We were filling the reservoirs because we wanted to make sure that there's enough water for irrigation and a whole range of other things, including drinking water for the later portion of the year. We forget that because we're looking up or we're looking at something else, that if you have extreme rainfall, you have to manage that regime effectively. And a classic example of how this has been dealt with is Surat. Surat has actually done a remarkable job. I had the unfortunate experience, or fortunate experience, of actually trying to help them manage the floods there of 2006. And what did we find? Very interesting. It's a systems problem. There's an upstream reservoir, which is 200 kilometers or 150 kilometers from Surat, which has all the water inside it. Surat is a city which has very high tidal range. Similar story to what happened in Mumbai, but Mumbai is at a much shorter scale. So the engineer who's managing the reservoir in Surat is looking up. There are no clouds there, there's no rain. His job is to manage the water resources as much as he could. Okay? What he doesn't realize, because it's a linked system, is 200 kilometers upstream of him, there's heavy rainfall happening in the upper catchment. The water is going to come down, it'll take 15 or 20 hours to come. Because of the way the system works, he currently only starts releasing water when his reservoir goes over the flood level. What he doesn't understand is downstream, when the water is released, the tide at Surat has gone up 5 meters and the city floods. And this happened in Surat 6 times. All that it required was a link system to inform people upstream and downstream of how this system is actually linked. And Chennai is similar, because what we were trying to do in Tamil Nadu was to manage for drought, but what we forget is that in a system like this, there will be both drought and flooding, and this will happen at more and closer frequencies. So I think looking at the process and linking it to the kind of systems that we manage is absolutely critical to our understanding of how to deal with this. So let me give you sort of another example of why culture is important in the process. Another city, the city of Lucknow, we worked on this many years ago, 20 years ago, on the environmental master plan, like of the city. And what did we find? We found a very interesting transition. Pre-colonial Lucknow was driven by gravity-fed systems. When Akbar settled Lucknow in the 16th century, he brought together all communities in different mohallas. And the system of water management and the management of communities were very tightly tied together. Why? Because in the lowest lying areas in a mohalla, you'll have a takya. Inside the takya, you had the wells. They were protected by green cover, and they had water available inside that. And of course, at that time, water was taken by mashak and supplied across the city. The British came, and of course, what happened in Lucknow in 1857, and they did two very dramatic things. The first thing is they blew up 1/3 of the city, which means they changed the entire fabric to be able to deal with defense and also to punish Lucknow because of what happened at the residency. And they built the civil and military station outside the old city area. The waterworks were upstream of the old city area, and they had a challenge of transporting the water with steam pumps at that time. This is 1890s, right under the city and to the civil and military station. What they did not understand at that time were two things. The first thing was that the settlement structure was very closely allied to the topography and process. And the second thing, and this we still make this mistake in the design of most of our systems, was that we had open drains at that point of time because the monsoon used to clear the silt. And we started applying hydrological principles, Manning's equation, a whole range of other stuff that were there, which came from a different environment. It came from Europe, which had a completely different system of rainfall and patterns of silt drainage. So, they tried to do a whole range of things with silt traps, but basically what happened very, very quickly was they had problems of flooding of drains and this thing of drains. And also they had serious problems of water shortages they never had over 250 years of the history of Lucknow, in spite of much, much higher densities of function. So how culture interacts with processes is very critical. And the other thing that they did, of course, was they destroyed the fabric of the green areas in the city that provided the spaces for the groundwater to be conserved. They moved it out because they said health considerations, you can't have burial places in the middle of the city, you have to move it out. It also mucked a whole range of other things. So then what did they have to do? They had to provide piped water supply. And the piped water supply was never enough for the black areas of the black town. It was only enough for the other areas. So you start with an intervention in the system in which you don't understand the fundamental basis of how that is evolved. And in many ways, we are replicating these processes in our industrial cities. And that's something that I'd like to sort of lay out for you. I'm not saying that we have to go back and understand and replicate exactly what happened before. Our throughputs are much larger than they are. But the principles that apply, the understanding of how the environment and society actually work together needs to be sort of tied down. So what drives this? And I sort of close with that. Yeah, thanks. 2 or 3 things. The first thing, and you may not be sort of, these are words that come from other disciplines or people. There was a famous American economist whose name is Kuznets. So, Kuznets has this thing which is called the Kuznets curve, which basically says that, for a country to become rich, you have to increase inequality. So inequality first increases and then it decreases. We have taken that idea and some people have applied it to environmental conditions, which basically says as the country becomes richer, first environmental quality will become worse and then it will become better. That's based on a theory of growth. Now, there is another very, very recent economist who about 2 years ago has actually destroyed Kuznets' idea. And the reason I'm laying out Kuznets is in many ways, some of the challenges that India is facing currently, and this is an ongoing debate in the development profession, of what actually will lead us to where we are, is driven with this idea that we have to grow very rapidly, and it really doesn't matter if our inequality is increasing. Yeah? And this is very important because inequality is increasing most dramatically in our cities. And what is the most obvious place in inequality and in increase of inequality? It's very simply, like in this city or any others, it's the access to water. Poor people in this city pay 5 to 10 times more for water than rich people do. Why? Because rich people have access to piped water systems and poor people buy it from tankers. And the tankers charge more for poor people even than people in gated communities. So, this wonderful idea that we have a great equity system doesn't work. So what Piketty, a French economist showed 2 years ago was Kuznets was wrong. He based his idea on a particular period of American history. And in the long run, the increase in inequality does not help economic development and growth. What implication does it have for us? And why does he say that? He says that for two very simple reasons. He says that the reason that this doesn't work in the long run is very simple, and that is the rate of return on capital, on finance, the stuff that we put in the banks, is higher than the rate of return on human capital or on physical capital. So basically what it means is that you put money in the bank rather than setting up an enterprise or doing work, it gives you more money. So what happens? More and more investment graduates into the financial sector, and this is true of India. So if you look at the form of built environments, in earlier days it used to be, the magnates used to run production systems or GE or electrical systems who had the biggest buildings. Which are the biggest buildings in the world at the moment? They're all owned by banks. I mean, this has been true for a long time. So he makes the argument about the fact that we are actually privileging financial capital over physical capital, the creation of physical things. And that, of course, people who labor and people who actually are producing physical capital are then at a disadvantage. I want to extend that question further and look at 4 different forms of capital. The lowest form of capital in our scheme of things is actually natural capital. We degrade it, the discount rates on it are extremely low, yeah, and that's why we don't value it. The next is human capital, which is probably India's most important resource. It's all of us, it's the people in this country. There again, the returns on investment in education, and I know there are many educators that are here, people don't look at education as an area that's really important because it's much better for you to do something else. How many people would go into the education sector because it's not something that's interesting? The second thing is the return on human capital, on education and health. The third thing is the return on physical capital. And the fourth thing is the return on financial capital. And if you look at the interest rates that you get on each one of them, you can see there's a dramatic differential. The highest interest rates that you'll get on financial capital, if you're on the stock market, you're on 12-13%. On ecological or natural capital, our returns on investment are either negative, because of the degradation, or they're extremely low. So if we have a system in which our built environment, the processes that drive our economies and societies are valued differently, and if we devalue the core resources on which our systems sort of function, it's no wonder that we land up in the mess that we have. The things that support us, we're not valuing, I would say, not even on equal terms, but on highly unequal terms. Why? Because we conceive of the world as a place in which you can go and build something and nothing will come back to you. In fact, I guess the key design principle that many of us have sort of learned, as many of you teach and learn in many places, is in a world that is full of people, you have to not build and then draw from the environment. You have to essentially design and conserve the ecological resources first and design everything else in the interstices. It's just the inversion of the 19th and 20th century idea that there's a frontier you can go and build, and this is true not only of the West but also of India. I mean, many of our towns are built like that. We have to invert that idea, and sitting behind the inverting of that idea is that we have to equalize the importance that we give to these different forms of capital, because those forms of capital create flows. The flows are our income, whether it's ecological income or physical income, and the people who actually control that become very rich. And if you look at inequality in our system, India's now it's got the largest growing population of billionaires in the country, and where they come from? They come from control over financial capital and knowledge resources. So I think the connection between these 3 or 4 have to be understood, and it has implications in the built environment, and especially, as I said, in the undervaluation of water, which is life in some senses. So when you value money over life, it's obvious that you have the landscapes that we have in. It's obvious that there will be both, illnesses and disequilibrium in the system at multiple levels. So I think the challenge before us is to really ask what is really important for us both in the short run and in the long run. And in the case of water, they both converge. Thank you very much.